Dynamic programming. Dynamic programming is a method for solving a complex problem by breaking it down into a collection of simple subproblems, solving each of these subproblems just once and storing their solution. This is also known as remembering the past. Dynamic programming is mainly applicable when the problem has overlapping subproblems. General approach of dynamic programming. The 4 steps that we need to follow to apply dynamic programming are: we first have to characterize the structure of an optimal solution. This steps involves finding the optimal structure of the problem. Then recursively define the value of an optimal solution. Finally, we compute the value of an optimum solution, typically in a bottom-up fashion. We can then reconstruct the optimal solution from the computed information. Steps 1 to 3 are the basic steps in dynamic programming. Step 4 is needed when we need not only the optimum solution but also the optimal value. First is the shortest path problem with dynamic problem. Shortest path problem is that we have to find the shortest path between any two given points. Say between two given cities, we have to find the shortest path between them. Approach. Step 1. Find if the shortest path problem has any structure of an optimal solution. The optimal path from city A to city B having city C on the way has the property that the paths between city A and B and between B to C are also optimal. Step 2. Write down a recursive definition of the optimal solution. Step 3. Compute the value of the optimal solution, typically in a bottom-up fashion. Step 3 gives you the optimal value, not only the optimal solution. In this problem, the optimal solution is the path that forms the shortest path between two given cities. Elements of dynamic programming. Optimal substructure. The optimal solution to a problem must contain in it the optimal solution to its subproblems. Whenever a problem exhibits this property, dynamic programming might apply. Overlapping subproblems. The space of subproblems must be small in the sense that a recursive algorithm for the problem solves the same subproblems over and over rather than always generating new subproblems. Memoization. The main idea of memoization is to maintain a table of solutions for the subproblems already solved. When we encounter the same subproblem again, we just fetch its value from the table instead of computing it again. Next is the Fibonacci series problem. To find the nth Fibonacci number in the sequence. We all must know the Fibonacci series, that is the sum of the first two numbers is a third number. Let us look at the computation of F4. So F4 will be F3 plus F2. Expanding F3 and F2, we can write F3 can be written as F2 plus F1, F2 can be written as F1 plus F0. Further, F1 and F0 cannot be further expanded as they form the best case because we start with F0 and we cannot break F1 further. So this is the base case. We cannot expand it further. So we expand only F2 in the above equation further and get. So here in this equation F1 and F0 cannot be expanded but F2 can be expanded. So F2 will be F1 plus F0 again. So the F4 will be finally F1 plus F0 plus F1 plus F1 plus F0. If we notice carefully, we calculated F3 one time, F2 2 times, F1 3 times and F0 4 times to solve F4. So Fibonacci series with dynamic programming. Why there is a need of dynamic programming? In this kind of problems where the divide and conquer does solve some subproblems more than once, we need algorithm which solve each subproblem once. So as in this previous example, we saw that how many times each subproblem is calculated. F2 you are doing it for 2 times, F1 you are doing it for 3 times, F0 you are calculating for 4 times. So this increases the complexity. So we need a solution in which each subproblem will be solved once. Hence the focus shifted to dynamic programming. One of the ways to do that would be memoization. It means that we have to store the solution of the subproblems that are already stored. In this case, each subproblem is finding the value of a particular Fibonacci number. If we encounter a subproblem of calculating a Fibonacci number, we see if its value is already memoized. If this value is found, we just use the value instead of computing it again. In this case, if we don't find the value, we compute and memoize it for the future use. So this is the figure of Fibonacci series with dynamic programming. We find the value of F6 using dynamic programming. So as you know, F6 can be decomposed to F4 and F5. F5 can be further decomposed to F3 and F4. F4 can be decomposed to F2 and F3. F3 to F1 and F2. Finally, F2 to F0 and F1. So since F0 and F1 are already calculated, this value is already there. We don't have to. This is also the base value. So again, when we move here, F2 will require F0 and F1, but this branch is no longer required because already F2's value is present. Similarly for F3, F1, F2, all these are required, but F1's value is already computed, F2's value is already computed. So this all branch is saved. All these are not required. For F4 also, we require value of F2 and F3 whose values are already present. So no longer we need this branching. The upcoming topics are rod cutting problem, railway station problem and integer knapsack problem. Thank you.